Hello and welcome back. So this is your second and final video for this week. Like I said, you only have 2 sets of Ready, Set, Go, which means you only have 2 video submissions. The third thing you guys will be doing this week is the quiz. So that quiz will be on Canvas. It isn't posted yet. I will hopefully get to that Monday. It should be posted by hopefully end of day Monday. If not, it will be on sometime on Tuesday. So during class, I will make sure to tell you guys about that. Hopefully by the time we have class on Tuesday, it will be on Canvas and available to you guys. But if not, I promise by end of day Tuesday, it will be on there. That way you have plenty of time to take and get that done. But first and foremost, you need to take and do the 2 sets of Ready, Set, Goes because they lead up to the quiz. So keep that in mind. So we are going to look at 7.7. So it has a lot to deal with circles, and it's going to be fairly similar to what your quiz is like for the most part. Not entirely. There's some parts that are not going to be on your quiz that are on here. So keep that in mind. Let's go ahead and dive right in. So for this first part, you can kind of see it here. We've got the 4 different circles, and we are looking to find what the circumference is for each of them. So looking when the radius is 1, when the radius is 2, when the radius is 3, and 4. And then same thing, finding the area when it's 1, 2, 3, and 4. So remember, the formula for circumference is 2 pi r. The formula for area is pi r squared. So for the circumference of a radius of 1, we take 1, we multiply it by 2, and then we multiply by pi. So we're going to have 2 pi for our answer there, and you can leave your answer in terms of pi. That's perfectly acceptable. Now, what should the area be when the radius is 1? So 1 squared is 1. 1 times pi is 1 pi. Now, how about when the radius is 2? What's the circumference? So 2 times 2 is 4. 4 times pi is 4 pi. Now look at the radius for area. The radius is 2. We're going to take and square it. So 2 squared is 4. 4 times pi. Once again, 4 pi. Radius of 3. Plug it into our circumference formula. So 3 times 2 is 6. 6 times pi. Leave it 6 pi. And last but not least, area. Radius of 3. 3 squared is, 3 times 3 is 9. 9 times pi is 9 pi. Now, I'm leaving the radius of 4 for you guys to do. You should be able to do this. You will be expected to take and find the circumference and area of circles on your quiz that you're going to take this week. So make sure you know how to do this. Make sure you know what these 2 formulas are, okay? All right, the next thing we are taking and looking at is ratios. So we have these ratios down here. So a ratio is a comparison between 2 quantities. The trigonometric ratios of sine, cosine, and tangent are ratios between sides in a right triangle. We can make ratios between many different quantities. So what we're looking at here is we want to write the ratios for the indicated quantities below. So the ratio of boys to girls in our math class, the ratio of boys to girls in your family. So each one of these, the first one you guys should all have the same because it's about our math class. But 3, 4, 5, and 6, those are going to be specific to you. So make them specific to your life and situation. So I'm going to do number 4 with you, the ratio of bathrooms to bedrooms in your house. Well, in my house, I have 2 bathrooms. Let me get my pen working on here. So I've got 2 bathrooms. And we use a colon symbol when we represent ratios. So that's the 2 dots that I did right here. And the number of bedrooms I have, technically my house is a 3-bedroom house. Now I don't use each of those 3 rooms as bedrooms, but it is a 3-bedroom house. So the ratio of bathrooms to bedrooms in my house is 2 to 3. So like I said, make this specific to your lives. I don't want you to have 2 to 3 down if it's not actually 2 to 3. Make it specific to your guys's. You don't live in my house, so don't have 2 to 3 if you don't actually have 2 to 3. So for 5, the ratio of televisions to people that live in your house. 6, the ratio of people in your house to cell phones in your house. So you're just looking at writing those ratios. So the first value, then colon, then the second value. So it's a comparison. So just like what I did on number 4. Alrighty. Okay, the next section. So we are looking at the circumference and area of circles and sectors of circles. So like I said, there's a lot to do with circles on here. Circles is your key word for this lesson. So circle is your key word for this lesson. All right, so we are going to do 10 and 12 together. You guys should be able to do 7 and 8. They're just like what you had to do on last week's assignment when you were given either the radius, circumference, or area and had to find the other two. That's exactly what these two are. So like I said, you need to know your circumference and area equations for circles. So what we're looking at on 10, so remember back to our area of a sector and arc length equations, because you need to know those. You also need to know area and circumference, so make sure you have those equations down in your workbooks somewhere. Make sure you know them. So for 10, I have it started. It told us that the arc length of AC, so from A to C, measures 16 pi. So I have the 16 pi equals, and then I looked at arc length. So C, remember C is the central angle. So in this, the central angle was 120 degrees, so 120 over 360 times 2 pi r. So we need to find what the radius is, so then we can solve to find what the area of the circle is, because we don't know what the whole area of the circle is. We just know what one section, the arc length of one section. So looking at this, the first thing I'm going to do is I'm going to reduce the 120 over 360 down so it's a little less confusing to look at. So 120 over 360 is the same thing as 1/3 times 2 pi r. So that makes it a little less crazy to look at. Now, both sides have a pi in them, so that means right off the bat, I know I can divide by pi. I also, both are even, so I can divide this 2 pi away. And yes, that's okay to divide 2 pi, even though we have the 1/3 there. They're all being multiplied together. So that goes away. Pi goes away here. 16 divided by 2 is 8. So we have 8 equals 1/3 r. So now to take and find the radius, we're going to multiply both sides by 3. So our radius is 24. So a fairly large radius for this. But this is not our final answer. We just needed this to take and solve to find what the area is, because it's asking what the area of the circle is. So remember, area equals pi r squared. So area equals pi times 24 squared, and 24 squared is 576. So our area equals 576 pi, and then we're dealing with, let's see, centimeters squared. Oops, sorry, you can't see that. So like I've said before, you can always leave your answers when we're dealing with circles in terms of pi. That's perfectly acceptable. You can also multiply it through. I will accept that as well. So that is for number 10. Now we're going to look at number 12. So very similar. It's telling us the area of the small sector is pi inches squared. And this time we want to find the circumference of the circle. So being as I knew the area of the sector, so area of a sector was pi equals the central angle, so it told me the central angle is 40, over 360 times pi r squared. So we have the equation there. Now, both sides have a pi in them, so I'm going to divide the pi out right off the bat. Now this pi divided by pi does not become 0. It becomes 1 equals, and I'm going to reduce my 40 over 360 right now as well. So doing 2 steps in 1, which gives me 1/9 r squared, because the pi cancels. Now, we need to take and get rid of the 1/9. So that means we're going to multiply both sides by 9. So that goes away. This becomes 9 equals r squared. Now, how do we get rid of a squared? We take the square root. So the radius equals square root of 9 is 3. Now, that's not our final answer. We need this to then find the circumference of the circle. So remember, circumference equals 2 pi r. So C equals 2 pi times 3. 2 times 3 is 6. So we have 6 pi inches. Oops. So make sure you read what the question is looking for. So some of them, it's going to be asking you for area. Some of them, it might ask you for circumference. Some of them, it may just ask you to take and find what the radius is. So be sure to read very, very carefully and make sure you know those equations. So it's all about working through the equation and solving it for a different value than what you would typically solve it for. Okay? All right. You will have questions about solving for area of a sector and arc length on your quiz. It will be the regular solving for area of a sector and arc length, where you're given the radius and you're given the central angle and you solve, rather than the reverse way. But you will have problems like that, so make sure you know that equation. All right, and the last section. Now, I know the second you see this, you're probably all starting to panic because none of you liked these problems on the last couple assignments. And I understand that. They are tricky. And these even more so because there's a lot going on in them. I am going to start each of these problems. I'm going to do 13 and 16 with you, and I'm going to start 14 and 15. So on 13, we are given the radius of the circle, which is also the radius of the pentagon. Now, we're going to use this and we're going to form a triangle to find the apothem, because remember, to find the area of a regular polygon, it's 1/2 times the apothem times the perimeter. So we have this right here. Radius is 8. I already started this out, as you can tell. So here was our figure. I know it's a little hard to see because it's really, really tiny, but there's our radius is 8. The apothem is from the center to the side of the figure in a perpendicular way. And then we have to solve for the side of our pentagon so we can find the perimeter. Now, using 36, so how I found the 36 is I took 360 and divided it by 5, which gave me 72. So that's the central angle. That'd be the full triangle from corner to corner, not when we split it down the middle. And then I divided that by 2 to find what just half of it is, since I split it in half. So that's how I got the 36. So using 36 as my angle of reference, I have the adjacent side and the hypotenuse, so I used cosine. So remember, you got to know your sine, cosine, and tangent. That is crucial for this. So we have cosine of 36 equals a over 8. Multiply both sides by 8. So we have 8 cosine 36 equals a. So I'm going to plug that right into my calculator. So 8 cosine 36. So that's going to give me about 6.47. Now, for those of you who don't have a calculator like this at home, you can use your phones. So remember, with this, you'd type in the 36, then hit the cosine, then multiply by 8. For those of you who don't have the extended calculator, you can take and Google calculator. Just go to Google and type in calculator, and it should give you the extended calculator. If not, you can also say trig calculator, and then it'll have the trig functions for you to be able to calculate with. So you are not incapable of doing this, I promise. There are ways around it. So we have our apothem. It's the 6.47. I'm going to erase this here. So area equals 1/2 times 6.47. Now we need to find the perimeter. So over here, once again, going back, our angle of reference is 36. Opposite side is x. Hypotenuse is 8, so we're using sine. So sine of 36 equals x over 8. So 8 sine of 36. So 8 sine 36. That's going to give us a 4.7. So now we're going to take that 4.7 and multiply it by 2 because that's going to give us the full length of the side. So 4.7 times 2 is 9.4. So that is this full side. So that is one side of the pentagon. Now, how many sides does a pentagon have? It has 5. So we have to take our 9.4 and multiply it by 5 to get the perimeter. So 9.4 times 5 is going to give us 47. So our perimeter up here is 47. So now we're going to plug all this in. So we're going to take 47 times 6.47 times 0.5, or 1/2. And so we're going to end up with 152.045. Now, this is not our final answer. Why is that? Well, the question says to find the area of the darkest shaded region. So the darkest shaded region is the area around the circle. It's the part in between the circle and the pentagon. So we're finding that part. So we know the area of the pentagon. Now we have to find the area of the circle. So area of a circle is area equals pi radius squared. We already know the radius. The radius is 8. So 8 squared. So 8 squared times pi. So 64 times pi is going to give us 201.06. And now what we're going to take and do, sorry, I forgot labels. This is meters squared, meters squared. Now we're going to subtract these two. So 201.06 minus 152.045. So 201.06 minus 152.045. And we end up with 49.015. Now, in the problem, it tells us, let's see, doesn't tell us what to round to, so we can leave it just like this, and our answer will be meters squared. So there you go. Hopefully that kind of makes sense. So this is going to be the process you have to do for each one of these. So on 14, like I said, I'm going to get it started so you can see how to find the apothem and how to find the half the side length. I'll get you to the full side length. Well, I'll get you to here. You'll have to find the 4.7 part and the 9.4 part times how much. So you're going to do that. And then finding the area of both the regular figure and the circle, and then subtracting them. Okay? It's going to be the same thing we did for 13 on 14 and 15. Okay? So on 14, we have an octagon. So there are 8 sides. So there's just a little heads up there for what you're going to multiply by to get your perimeter. For our central angle, we took 360 and divided it by 8. That got us 45. 360 divided by 8 gave us 45, and then 45 divided by 2 gives us our 22.5. So that's how I got this central small angle on my triangle of 22.5. I know it's a little hard to see. Our radius, like it says here, is 10. So finding the apothem, adjacent, and hypotenuse, so it's going to be cosine of 22.5 equals apothem over 10. So 10 cosine 22.5 equals the apothem. You're going to plug that into your calculator and find out what that is. I'm not doing it for you. Now, to find the x value, so to find half of your side length of your octagon, you're going to take and do sine of 22.5 equals x over 10. So 10 sine 22.5 equals x. So x equals. Now remember, you're going to take what x equals, you're going to multiply it by 2. Then you're going to take what that equals, so you're going to have an answer here, multiply it by 2. Then you'll have an answer here, multiply that by 8. That equals your perimeter. So remember, that is your perimeter. So then you'll plug your perimeter in up there. You plug in what your apothem is up here. Find that area. Then find the area of the circle. Area of the circle equation is not going to change. You're just going to change what the radius is. So in this case, it'll be 10. So you'll have 100 pi. Find what that is. Take that. Subtract what the area of our octagon is. Okay? So all you're doing is solving 10 cosine 22.5, solving 10 sine 22.5, multiplying that value by 2, and then again by 8, then multiplying these two things together and dividing by 2, then subtracting the area of the circle and this from each other. Okay? All right, the next one, and let me just show you what that one looked like quick before I move on to the next one. So this was the octagon one, okay? So you're finding that dark section around there. So it's going to be a fairly small number because obviously there's not a lot of space between our octagon and our circle. They're fairly close together. All right, the next one we're looking at is 15. So getting that one set up for you guys. So it's a rectangle inside the circle, so there's a lot of space going on. It was nice and gave you what that angle right there is. They were so nice. So we have a 60-degree angle for our central angle, which I have marked on there. Our radius is 5, which is also marked. We still need to find the apothem and half of that side length. So it's the same setup. You're always going to do cosine and you're always going to do sine. So cosine to find the apothem, sine to find the side length. So cosine of 60 equals apothem over 5. 5 cosine 60 equals apothem. Apothem equals, that's what you get to find. Then for half your side length, you're going to have sine of 60 equals x over 5. So 5 sine of 60 equals x. So x equals something. Now, in this case, yes, you are still going to multiply it by 2. So we're going to take that value. I'm actually going to find what this is for you just because this one's a little different. So sine of 60 is 4.33. You're going to multiply that by 2. So 4.33 times 2 is going to get you 8.66. Now, because we're dealing with a rectangle, we don't multiply this by 4. We only have to multiply it by 2 because there's two sides that have a length of 8.66. The other two sides are both 5. Because remember, opposite sides are congruent to each other. And it told us, see this shorter side over here, is 5. So multiply your 8.66 by 2, and you get 17.32. So your perimeter, so area equals 1/2 times whatever your apothem is, times 18.32. We just add 10 to it. So your perimeter is 18.32. So I got you what your perimeter is on that one. All you have to do is find the apothem, multiply the perimeter and the apothem together, divide by 2, find the area of the circle, and subtract those two things. Okay? All right. The last one. And once again, I said I am doing 16 with you because there's a lot of stuff going on in 16. So we have 2 triangles in this one. Fun stuff. So the radius is 5, our central angle. So it's telling us this angle right here is 60, but we need to split that in half so we can find our apothem. So our angle is going to be 30 here. So I have cosine of 30 equals the apothem over 5. So 5 cosine 30 equals A. 5 cosine of 30 is 4.33. Now, we don't actually have to find what this side is because if we notice, this side here, DC, and side DE, those are both radii of the circle, so they're both 5. If these two sides are both 5 and this angle 60, both of these angles are also going to be 60 because this ends up being an equilateral triangle. So that means this side CE is also 5, so half of it would be the 2.5 we have there. So now, because we have triangles, we don't have to use the 1/2 the apothem times the perimeter. We actually just get to use our 1/2 base times height, our formula we're pretty used to. So our height is our apothem in this case of the smaller triangle here. So for the small triangle, we're going to have area equals 1/2 the base. So our base is this side here, which I said was the 5. So times 5 times our height, which is 4.33. So we're going to take 5 times 4.33 times 1/2, and we get 10.825. Let's see, what's our unit? Centimeters squared. Sorry. Now we're going to do the big triangle. So on this big triangle, if you look down here, the base of this triangle is the diameter of the circle. So if the radius is 5, the diameter is 10. So we have 1/2 10 times. Now the height, being as the vertex of this circle, or the vertex of this triangle is on the circle, that means the radius is also the height of the circle. So the radius was 5. So we have 5 times 10 times 1/2, which is going to give us 25. So our area here is 25 centimeters squared. Now, we have to add these two together because we need to know the full area of the two triangles so we can subtract it from the circle. So we're going to end up with 35.825 centimeters squared. So now we know the area of both the triangles. Now we need to find the area of the circle. So area equals pi. Our radius we know is 5, so 5 squared, which equals pi times 25. And so 25 pi is 78.54. So this is 78.54 centimeters squared. Now, we subtract the 35.825 from that. So 78.54 minus 35.825 is going to give us 42.715 centimeters squared. So the area of the darkly shaded section on 16 is 42.715 centimeters squared. So hopefully having those two fully done for you guys helps you figure out how to do the other two, as well as the fact that I started each of the other two for you. So use what I've given you to help you. Remember, the key word for this lesson is circle. We did a lot with circles. Make sure you know how to find the area of a circle. Make sure you know how to find circumference. Make sure you know how to find the length of an arc and also the area of a sector. You guys will have a quiz over all of that stuff right there. So, like I said, there will not be any areas of regular polygons. You do not have to worry about that whatsoever on this quiz. So don't let that freak you out, okay? The quiz will be under assignments on Canvas, so make sure you look there. If you get stuck, feel free to shoot me an email, and I can walk you through getting there with a Zoom call if need be, because I can show you the screen and exactly how to get there. That way, we can make sure that you get it done. All right? All right. Have a wonderful week. Happy mathing.